Hi everyone, this is practice formative of chapter 4, permutation and combination. It's question number 9. So we need to find the value of n for each of the following. So we have np2 equals to 6. So we need to find the n. We shall use the formula of npr. We will have n factorial over n minus r factorial. So use this and apply into A. So np2, that will be n factorial over n minus 2 factorial equals to 6. Now, what's next? We can expand the n factorial. We will have n times n minus 1, n minus 2, but we stop here because I want to simplify the n minus 2 factorial from both numerator and denominator. So over here, we will then have cancel this. Okay, so we will have n times n minus 1. That will be n squared minus n, and bring the 6 across to the equation. So we will have minus 6 equals to 0. Therefore, let's factorize this. We have 3 and 2. Negative and positive equals to 0. Therefore, n equals to negative 2 or n equals to 3. We reject this as n is always greater than 0, but it's always positive. Okay, so we found the value for n, that is 3. Next, part B. Same thing, we'll apply the formula n plus 2 factorial over n plus 2 minus 3 factorial equals to 42n. Okay, let's expand. We have n plus 2 and then the term minus 1. So we have n plus 1 and then continue n and then n minus 1 factorial, because at the denominator, we have n plus 2 minus 3, that is n minus 1 factorial. So equivalent to 42n. Let's simplify the n minus 1 factorial away. So on top, we left with n times n plus 2 and n plus 1. So we expand this. We will have n squared plus n. And then continue, we have 2n plus 2 multiply with the n equals to 42n. So the n and the n, we can actually simplify it away. So n squared plus n plus 2n plus 2, which is n squared plus 3n plus 2 equals to 42. So bring the 42 over, minus 42. Okay, so with that, we simplify before we factorize. We will have n squared plus 3n minus 40 equals to 0. So let's factorize this. 8 and 5. To get positive 3, we must put positive at 8, negative at 5. Double check. The inner pair give us positive 8n. The outer pair give us negative 5n. Therefore, the sum will be positive 3n. Okay, so once we double check, it's correct. Therefore, the factorization is correct. Next, let's find the n. N equals to negative 8, which we reject because n must be positive. Okay, n equals to 5. So that's it. That's the answer for number 9B. Next, part C, we expand using the formula. So we have 7, and therefore n plus 1 factorial over n plus 1 minus 2 factorial equals to 5. Okay, so n plus 2 factorial over n plus 2 minus 2 factorial Okay, so expand the n plus 1 factorial until we see the n minus 1 factorial, because the denominator, we will get n minus 1 factorial. Let's write down n minus 1 factorial. So we expand the n plus 1 factorial into n plus 1 times with n minus 1 factorial equals to 5. The one at the bottom is n factorial. So n plus 2, n plus 1, and then n factorial. So let's simplify. The n minus 1 factorial simplified with the n minus 1 factorial. N factorial simplified with n factorial. Now, so for each term, we expand. Okay, let's expand. So we have 7 n squared plus n equals to 5 n squared plus n plus 2n plus 2. Okay, next, we will then have 7n squared plus 7n equals to 5n squared. 1 plus 2 is 3. 3 times 5, 15n plus 10. Okay, group everything to the left side. So 7n squared minus 5n squared, we have 2n squared, and then plus 7n minus 15n, so negative 8n, and then minus 10 equals to 0. Always simplify before we factorize. So everything divided by 2. So we will have n squared minus 4n minus 5 equals to 0. Let's factorize this. We have 5n1, and negative go to the big number. Double check. The inner pair is negative 5n, and then the outer pair is positive n. So negative 5 plus 1, we have negative 4n. Therefore, n equals to 5. And another one, n equals to negative 1. We shall reject this, as n can never be negative. So we found the answer for 9C, n equals to 5. Next, part D. So for part D, let's look at it. So for part D, let's apply the formula. We have 2n factorial over 2n minus 2 factorial, equivalent to 3 times n plus 1 factorial over n plus 1 minus 2 factorial. So for the left-hand side, okay, we expand the 2n factorial. That will be 2n times with, always reduce by 1 at each time when we move on. So 2n minus 1 and then 2n minus 2 factorial. Okay, therefore the 2n minus 2 factorial, we can simplify. Okay, not forgetting the right side. The right side, we will have 3, and then we have n minus 1 factorial. So n plus 1, let's expand this part, n minus 1 factorial. So simplify this. So on the left, we have 4n squared minus 2n, and on the right, we have n squared, 3n squared plus 3n. Okay, let's move this side to the other side. So we have 4n squared minus 3n squared. We will have 1n squared minus 2n minus 3n minus 5n. Therefore, n minus 5 equals to 0 is either n equals to 0 or n equals to 5. So in this case, we choose n equals to 5, not 0, because n must be greater than r.